Hello and welcome to my presentation on our paper Predicting Readability from Scroll Behaviour. My name is Sian Gooding and this was work done with Yevgeny Berzak, Tony Mack and Matt Sharifi. So to start off with, what is readability? So readability is all about how difficult a text is to read. So if you look at these two examples here, we have Crime and Punishment by Dostoevsky and Winnie the Pooh, which is a children's book. And there are different features of these texts that make one more difficult to read or a more advanced level than the other. And when people first started trying to quantify readability, they started off by using formula-based approaches. So probably most people have heard of Flesch-Kincaid. And in these approaches, they kind of use surface level peripheral features of text, such as how long the text is, how many sentences there were, how many words and how many syllables. And clearly using these surface level features can only get you so far when you're trying to predict how readable a text is. And so subsequent research looked at machine learning techniques to be able to do this. And the use of machine learning meant that you could integrate more sophisticated features such as the syntactic constructs, coherence, word complexity, these types of things. And part of the reason that predicting readability is really useful is for applications such as in text simplification. So if you want to simplify text, you have to reason about how readable it is. And also things like actually matching text to language learners. So if you're learning a language, you might need text at a particular level. So it's really useful to be able to judge how readable a text is and match it to the specific audience. However, traditional readability measures don't work very well for web applications, so some of the applications that I was talking about. And there's two main reasons for this. The first is that they typically assume content has well-formed sentences. And as most of us know, if you're working with online text, often it's can be broken, it can have images in it, and it can be noisy. So this is a problem with both the kind of formula-based metrics and also the machine learning approaches. And not only this, but they lack user subjectivity. So whilst a lot of these ways of predicting readability focus on the kind of objective level of the text, there's also a way of leveling text that takes into consideration the level of the particular user. And so we know that on-device reading has predominantly taken the place of traditional format. So most people now are reading on phones, devices, iPads. And this gives us a really unique opportunity to actually be able to observe how people interact with text as they read. And so in this study and this paper, we're really looking at what can reading interactions tell us about readability. And so in our study, there's kind of three main steps. So we perform a study with 600 participants. After pre-processing, we ended up having 518. And the high-level overview of this is that we present participants with text at different readability levels. So we have two levels. We have advanced text and elementary text. We show these to participants and ask them to read them. And as they read these, we measure the user interactions. So we measure a variety of different things in how they interact with the text as they're reading it. And then we ask a set of comprehension questions. And the comprehension questions asked after each text has been read. And these give an indication of how well a reader's actually understood what they've been presented with. And the dataset that we use for this is One Stop QA. So this is a dataset that has text at different levels. And the really good thing about this dataset is that it has comprehension questions, which are designed to be very difficult to guess the answer to. So they give quite a good indication. If people are getting these answers right, it's a good indication that they've actually understood what they've read. And so, as I said, once we present these texts to readers, we measure the interactions. And there's two kind of groups of interactions that we measure. The first are a set of scroll measures. So this is things like the speed, the acceleration as they scroll through. So you can see on the right here, there's an example of someone scrolling through a text as they read. And things like the regression number. So do they recover areas of text as they read? And then we also look at a bunch of time measures as well. So how long does it take them to read it? How long does it take for a first pass? And the first question that we wanted to ask is, do reading interactions differ depending on the difficulty of text? And we do this using a mixed effects model. And we find that actually, yes, there are a set of ways that people interact with text that will differ significantly depending on how difficult the text actually is. So some of these are quite intuitive, such as the average speed. So obviously, if a text is more difficult, you're more likely to read it slowly. And so once we'd seen that there were interactions that differ depending on the text level, we then wanted to see whether we can actually predict the readability of a text based on interactions. So as I said at the beginning, predicting text readability, it's all about actually assigning a level to a text. And so the way that we try and set up this experiment is that each text in our data set is read on average 6 times. And so we take the mean kind of measure from these 6 different interactions, and we input this into a classifier. And this classifier is trained to predict whether this text is a hard text or an easy text to read. So yeah, it will output a level such as advanced or elementary. And we find that actually using scroll features alone, we're able to get an F score of 0.77. And this is quite an interesting finding because firstly, this is the first work that's really looked at readability from this interaction-based viewpoint, but also this has absolutely no features of the text itself. So it's only based on how people have interacted with that text. And we also see that if we actually combine scroll features with some classical lexical features, we're able to get a really quite a good score. And this is really good because it shows that these scroll features can actually be integrated in traditional readability approaches. And then finally, we wanted to know, are there group differences in reading interactions? And one of the ways that we investigate this is that we do a TS&E plot of different interaction measures, and we colour this by score. And the idea behind this is we wanted to see whether there were different types of interactions that take place that indicate how likely it is someone's actually understood what they've read. And you can see here there's quite a clear pattern that emerges there. And we also see that generally interaction trends vary based on the first language and score. So this really speaks to the idea that you can predict a subjective level of readability and see how well someone's actually understanding a text based off how they're interacting with it. And so to conclude, there are statistically significant differences in the way readers interact with text at different levels. Scroll features can be used to predict the readability of text. And implicit user feedback, or the way people interact with text as they read, gives us an insight into how readable a text is for them as an individual. And our data set is made available here, and hopefully we'll see you at the poster session if you have any questions. Thank you.